potassium. For potassium, it is K1939. Students find it difficult and make mistakes in drawing the electronic configuration of potassium. There are 19 proton, and number of protons and number of electrons are equal, so 19 electron. Neutrons, we can find the nucleon number equal to proton plus neutron. Nucleon number are 39, equal to protons are 19, and we can find neutrons, which are 39 minus 19, and they are 20. So we have found out the number of proton, electron, and neutron in potassium, and this is the method we use to find the neutron. And we can find the period number. You know very well the priority of the period number is the first priority. So the first priority is given to the period number. So the period number of potassium is 4. So the period number potassium belongs to 4, and the group number potassium belongs to 1. So period number tells us the number of shells in potassium, which is 4. So there are 4 shells in potassium. The group number is 1. So the group number tells us the number of electrons in the last shell. So in the last shell of potassium, there is only 1 electron. And you know very well that priority of the period number is the first. So protons are 19 and neutrons are 20 in the potassium, and the period number is 4, and that must be given priority number 1. So we are going to draw the period number 4. So there are number of shells which are 4. So the first shell, second shell, third shell, and the 4 shells. So first of all, we should make number of shells, and number of shells depend upon the period number. And potassium belongs to period number 4, so it has 4 shells. The second priority will be given to group number, and it is group number 1, so it is having only 1 electron in the last shell. Then the first shell can maximum have 2 electrons, second shell can maximum have 8 electrons. You can count the total number of electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We have to make 19 electron. To make 19 electron, this shell, the second last shell, must have 8 electrons. If you draw electronic configuration with this, you will not have any chance to make any mistake. So whenever you are going to draw the electronic configuration, the first priority will be given to the period number, the second priority will be given to the group number. And the period number tells us the number of shells. So number of shells are 4, so there are 4 shells, group number is 1. So group number tells us the number of electrons, so it has 1 electron in the last shell. Then you start from the first shell maximum have 2 electron, second shell maximum have 8 electron. The second last shell electrons must be added at the end of it, with respect to the total electrons are 19, 2 electron the first shell, 8 electron the second shell, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the last shell 1 electron, and the remaining electron must be added in the second last shell. In this way, our chances of making mistake will be eliminated. So I am going to draw the electronic configuration for sodium. For sodium, it is 1123. So this is a smaller number. Smaller number means the proton number. Proton number are 11. Electrons are also 11. Neutrons are 23 minus 11, which are 12. And period number, you have learnt it, I think, that the priority number 1 must be given to the period number. So the sodium belongs to period number 3. So there are 3 shells around sodium. The sodium belongs to group number 1. So there is only 1 electron in the last shell of sodium. So if we draw the electronic configuration, protons are 11, neutrons are 12. As the priority will be given to the period number, which is 3, so number of shells are 3. You should draw 3 shells around sodium. The second priority will be given to the group number. Group number is 1, so it tells us there must be 1 electron in the last shell. So this is how I have made it, and then we should take a start from the first shell. First shell can maximum have 2 electrons. Second shell can maximum have 8 electrons, and we have 11 electrons. We have to make 11 electrons in total. So count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And this is how we have made the electronic configuration of sodium. So I like to repeat that when you have to draw the electronic configuration, priority number 1 must be given to the period number. Priority number 2 should be given to the group number, and the last priority will be given to the 2n square rule. And period number tells us the number of shells. So number of shells must be, if in case of sodium, 3, so we draw the 3 shells, and the second priority will be given to the group number. It is only 1 group number, so there must be 1 electron in the last shell, and then you start from the first shell and the second shell, and in this way we can make the electronic configuration without making a mistake.